Alrighty, study guide problem number 4. On the moon, the acceleration due to gravity is negative 1.6 meters per second squared. So I'm going to say A of t equals negative 1.6. Pardon me. If a stone is dropped from a cliff and hits the surface of the moon 10 seconds later, already I'm thinking, oh, I don't want P of t. Let's say H of 10 equals 0. That says after 10 seconds, the height is 0. We're going to need that later. But let's go back here. If a stone is dropped from the cliff, hits surface 10 seconds later, how far did the stone fall, and what was the velocity of the stone at the time of impact? So I need to integrate this acceleration function to get a velocity function. So if I integrate negative 1.6 with respect to time, I'm going to get the velocity with respect to time equals negative 1.6 t plus c, our constant of integration. But since the stone is being dropped, it's not being thrown down or thrown up, v naught, our initial velocity, is 0, which if you remember in this case is just our constant of integration. So that's actually just going to go away, and we're going to get v naught equals negative 1.6 t. Sweet. Okay, let's integrate again to go from our velocity function to our position function, h of t. So if we integrate again with respect to t, we're going to get negative 1.6 times t, raise our power up by 1, so we're going to get t squared divided by our power. Negative 1.6 divided by 2 is going to give us negative 0.8 t squared plus c, our constant of integration. Now we got to use that fact, h of 10 equals 0, and we could say 0 equals negative 0.8 t squared. Sorry, I don't want t because t is 10, so 0.8 times 10 squared plus c, and then if I solve that out, negative 0.8 times 10 squared is 100. 100 times 0.8 is 80, so we get negative 80 plus c equals 0, and then we'll get c equals 80. So I get my function h of t equals negative 0.8 t squared plus 80. Okay, remember that 80 there, that represents our initial height. So part A, how far did the stone fall? Stone fell 80 feet. Part B, what was the velocity at the time of impact? Well, the stone hits the ground at 10 seconds, so plug that into our velocity function. Where is that? Right here, negative 1.6 times 10. We're going to get negative 16 feet per second. And we are done. We're feeling good. We're happy. Life is awesome.